So now that we know what I is, I want to show you how to apply that to raising I to different powers. Okay, so we know that I equals this. It's equal to the square root of -1. Okay, we also know that if we square the square root of -1, if we take this thing here and we square it, those will cancel and it will just leave us with -1. Okay, so we'll make kind of a chart right here. So I to the first power, another way of saying that is just I. I to the second power equals -1. Okay, let's find this now. So I to the third, hopefully you would agree that I to the third is the same as that. Raising something to third power means times itself 3 times. Okay, well this right here, that's the same as I squared. And then we still have that I right here, this I to the first. But we already know that I squared is equal to -1. So we could say that I squared times I is the same as -1 times I. And -1 times a variable is the negative of that variable. In the same way, -1 times I would be -I. So we'll put that right here. So that's equal to -I. Okay, I to the fourth is the same thing as I squared times I squared. You can think of it this way. It's I times I times I times I. This is I squared, and so is that. So another way of saying I to the fourth is I squared times I squared. What is I squared equal? We said up here that I squared equals -1. So I squared times I squared would be the same as -1 times -1, and that equals +1. Okay, here's the idea. If you know these four right here, if you know that I to the first is I squared is -1, and the same for the other two. If you know those four, you know I raised to any power. And I'll show you why. So I to the fifth is the same as I to the fourth times I to the 1. If we were to add these exponents together, we would get that. We just found out that I to the fourth is this. So I to the fourth times I is the same as 1 times I, which is just I. Let's kind of do one more pattern right here just to see, so you can see how this repeats. So that's I to the eighth. I to the sixth is the same as I to the fourth times I squared. We already know that I to the fourth is 1, and we already know that I squared, we found it up here, it's -1. So 1 times -1 equals -1. Okay, I to the seventh is the same as I to the fourth times I to the third. We know I to the fourth is 1. We also found I to the third before, it's right here. So 1 times -I is -I. And then finally I to the eighth is like I to the fourth times I to the fourth, which is like 1 times 1, and that equals 1. So notice the pattern goes I, -1, -I1, I, -1, -I1. So the pattern repeats every 4. Okay, the pattern repeats every 4. So here's how you can find I raised to any power. Let's suppose we had a huge number like I to the 12,893. We don't want to have to count through this pattern. I, -1, -I1. We don't have to want to do that repeatedly. So here's the easy thing to do. Take this number right here and divide it by 4. And whatever the remainder is, it's going to be either this one, this one, this one, and if it has no remainder at all, because 4 divided by 4 doesn't have a remainder, if it has no remainder at all, it's going to be like I to the fourth. So here's what I mean by that. That might be a little bit confusing. I to the fifth, if I take this number and I divide it by 4, 4 goes into 5 once, and it leaves us a remainder of 1. So I to the fifth has the same value as I to the 1. Okay, I to the 1, you might remember it equals just I. Let's try that with 6. If we take 6 and we divide it by 4, we get 4 goes into 6 once, and it leaves us a remainder when we do that division of 2. So I to the 6 is equal to I to the 2, which is -1. Okay, we have that right here. And we came up with that using the pattern. So the idea is take the exponent, divide it by 4, and whatever the remainder is, it's going to be one of these 4 right here. Here's a nice shortcut too. When you're dividing a number by 4, you only need to look at the last 2 digits to see if 4 goes into it. So for example, if I have a huge number like 1,000,012, let's say, since 4 goes into 12, I know that it goes into that whole number. I only ever need to look at the last 2 digits when I'm dividing by 4. So in this case, all I need to look at is the 93, because that's an 893. It ends in 93. I'm going to divide that by 4. 4 goes into 93 23 times. Okay, we're going to bring that down. 4 goes into 13 3 times. And all we care about is the remainder. The remainder is 1. So that means this huge number right here is going to behave like I to the 1, which is just equal to I, as we know from this table right here. All right, let's do 2 more just to make sure that we have this down. So I'm going to box this off a little bit. Let's try I to the 842, and after that let's try I to the 900, or let's say 9,472. Okay, so again, the strategy is we only need to look at the last 2 digits, and we're trying to see how many times does 4 go into that. 4 goes into 42 10 times with a remainder of 2, and that tells us, the remainder of 2 tells us this is going to be like I to the 2, which according to this chart right here equals -1. So I to the 842nd power is equal to -1. Okay, this one here, again, we only need to look at the last 2 digits. 72 divided by 4 is 18, and it does not have a remainder. So out of these 4 numbers here, what's the only one of these 4 numbers? 1, 2, 3, or 4? What's the only one that does not have a remainder when you divide by 4? And the answer is 4. 4 goes into itself once, and it has no remainder. So if it has no remainder at all, which this huge number here doesn't, it's going to behave like I to the 4th, and I to the 4th equals +1. So that's how you raise I to different powers.